Welcome to Science Bids, where we explore the frontiers of science. Today we're diving into experiments that challenge our understanding of time. In everyday life, time seems to move in one direction because processes like melting ice and scrambled eggs are irreversible. Physicists call this the arrow of time. It's deeply connected to the second law of thermodynamics, which says that disorder, or entropy, tends to increase in isolated systems. But at the microscopic level, the laws of physics don't prefer a direction, so why do we? In 2019, a team led by Argonne National Laboratory used IBM's quantum computer to simulate an electron scattering off a two-level quantum system. Then they ran the evolution in reverse. The algorithm restored the system's initial state with about 85% fidelity. They only measured the system at the beginning and end to avoid disturbing it. This isn't time travel. Reversing a macroscopic system would require an impossibly large machine, but it shows we can nudge quantum states back in time. In 2022, researchers at the University of Vienna and the Institute for Quantum Optics and Quantum Information devised a universal time reversal protocol. By exploiting the non-commuting nature of quantum operators, they showed that a process can be rewound without knowing its details. They used a quantum switch that places a photon in a superposition of two sequences of operations. Their photonic experiment achieved over 95% fidelity, and the method can, in principle, succeed almost every time. Fast forward to 2025, scientists at the Austrian Academy of Sciences and the University of Vienna took the idea further. They evolved a single photon through a crystal and used a quantum switch to bring it back to its original state. Miguel Navasquez compared it to using a remote control. You can rewind or skip ahead, and the protocol works even if you don't know what happened to the photon along the way. They even figured out how to fast forward a system. By taking 1 year of evolution from 9 identical systems and giving all of it to the 10th system effectively aged 10 years. Don't worry, you can't do this with humans. Rewinding 1 second of a person's life would take millions of years. Around the same time, theorists at the University of Surrey asked a fundamental question: could the arrow of time emerge from interactions with the environment? Their open quantum systems model showed that, under reasonable assumptions, the equations of motion are symmetric, whether time flows forward or backward. They discovered a memory kernel that preserves time symmetry and found that the difference between spilled milk and a swinging pendulum comes from coarse graining the environment. Finally, let's talk about negative time. In 2024, University of Toronto physicists shot photons through a cloud of ultra-cold rubidium atoms. Surprisingly, they measured negative dwell times. Photons seemed to exit before they had fully excited the atoms. This isn't sorcery, it's quantum superposition. The measuring device ends up in a superposition of measuring 0 and measuring a positive time. Interference between these outcomes can give a negative result. It doesn't violate relativity or enable time travel. So what does all this mean? These experiments show that time can be manipulated at the quantum level, but they don't let us send people to the past. They might, however, lead to better quantum computers and deeper understanding of why time seems to flow one way. Summarize potential applications such as quantum error correction and quantum sensing. Mention that theoretical work suggests the arrow of time arises from statistical effects, not fundamental laws. The quantum world keeps surprising us, and reversing time is just one example. If you enjoyed this video, give it a thumbs up and subscribe for more mind-bending science. What topic should we cover next? Let us know in the comments. The future is built by Science Bids.